Number 1. Movile Cave, Romania. You are descending a vertical shaft cut into limestone near the Black Sea coast of Romania. The narrowest point is about 25 centimeters wide. Your rope creaks. The light from the surface disappears. And the air changes. Not gradually, it changes like a door closing behind you. Oxygen down here sits between 7 and 10%. At the surface, you breathe 21. Carbon dioxide hovers at 2 to 3.5%. At the surface, it is 0.04. Hydrogen sulfide floats at 1 to 4 parts per million. Enough to smell. Enough to corrode metal. Researchers who enter are limited to 5 or 6 hours before hypoxia and hypercapnia begin shutting down cognitive function. After that, you stop making good decisions. And in a cave like this, bad decisions are final. Movile Cave was not found by scientists. On September 29, 1986, a Romanian geologist named Cristian Lascu was surveying the ground near Mangalia, Constanța County for a potential power plant. An infrastructure project cracked open a biosphere that had been sealed for approximately 5.5 million years. The cave sits 18 to 25 meters below the surface in Jurassic-era limestone of the Dobrogea Plateau. It sealed during the Messinian salinity crisis, when shifting regional hydrology and overlying sediments closed every entrance. Since then, nothing has gone in. Nothing has come out. The temperature inside holds steady at 21 degrees Celsius. Humidity sits at nearly 100%. These conditions have been essentially static for millions of years, thermally buffered by geothermal influence from below. And on the surface of the cave's lake, floating across the walls and ceiling, there is a white microbial mat. It coats everything. This is the ecosystem's meadow. It is powered not by sunlight, but by sulfur-oxidizing bacteria that pull energy from dissolved hydrogen sulfide rising through the rock. 0 photons. 0 organic input from the surface. The entire system runs on chemistry. In 1996, Serban Sarbu, Thomas Kane, and Brian Kinkle published a landmark paper in Science, volume 272, pages 1953 through 1955. They proved the food web was entirely chemoautotrophic, the first terrestrial cave system ever documented running on chemosynthesis alone. Approximately 57 animal species live here. Between 33 and 48 of them are endemic, depending on which taxonomic revision you follow. All invertebrates, no vertebrates. The blind water scorpion Nipe and Nophthalma belongs to a family that normally has eyes. It evolved blindness here. The gastropod Hadziella movilensis, the amphipod Nephargus dansawawi, and Romanobathinella dobrogena all exist nowhere else on Earth. Above them in the food chain sit spiders, pseudoscorpions, centipedes, and leeches. This is not just a bacterial film. It is a multi-trophic predator-prey system sealed in darkness. 2 chemosynthetic pathways run at the base: sulfide oxidation and methane oxidation, more metabolically complex than anyone initially assumed. The mainstream theory holds that the ancestors of these species were Tithian, sea margin organisms from the Miocene. They colonized the cave before the seal event and evolved in isolation over 5.5 million years. Phylogenetic divergence data supports this. An alternative theory proposes multiple colonization waves before the final sealing, with different lineages entering at different times through hydrological connections that no longer exist. This would explain the unusual taxonomic diversity for a sealed system. A more speculative theory, drawn from Radu Popa's metagenomic work, suggests some of the microbial lineages may predate the cave's sealing entirely. They may be remnants of deep crustal biospheres already present in the Jurassic limestone long before the cave formed. Metal equipment corrodes rapidly in the hydrogen sulfide atmosphere. The cave is a protected nature reserve, sealed with a locked hatch. Access requires official Romanian government scientific permission. Fewer than approximately 100 people had entered by the mid-2010s. The cave is actively enlarging through sulfuric acid speleogenesis. The bacterial mat produces sulfuric acid that slowly dissolves the limestone, the same process that carved Lechuguilla Cave in New Mexico. And NASA considers Movile Cave its primary terrestrial analog for potential subsurface life on Mars or Europa. Not because it hosts single-celled extremophiles, because it hosts a complex multi-trophic ecosystem that has survived sealed for geological timescales. But Movile is a single cave, A single shaft, a single sealed chamber. What happens when the trap is not one room, but an entire drowned continent of tunnels stretching hundreds of kilometers? Number 2. The Yucatán Cenote Underworld. The Yucatan Peninsula sits on a karst limestone platform 1,500 to 3,000 meters thick. It was laid down during the Cretaceous and Paleogene. During the Pleistocene glacial maximi, sea levels dropped 100 to 130 meters. Rainwater turned acidic with dissolved carbon dioxide and ate through the exposed limestone, carving an underground labyrinth. Then the ice melted, the sea rose, and the caves drowned. Sistema Sac Octun, near Tulum, is the longest known underwater cave system on Earth, approximately 368 kilometers of mapped passages. In January 2018, Robert Schmittner's Gran Acuífero Maya project team connected it to Sistema dos Ojos, merging two enormous networks into one. And the system follows a pattern. The ring of cenotes traces a semicircular arc along the inner rim of the Chicxulub impact crater. The asteroid that ended the dinosaurs 66 million years ago fractured the subsurface rock along the crater's peak ring, creating preferential dissolution pathways. The craters of mass extinction became the architecture of preservation. An estimated 6,000 to 10,000 cenotes dot the peninsula. Only a fraction have been explored. In 2007, divers Alberto Nava Blanc, Bay Guenther, and Franco Attolini discovered Hoyo Negro. Black hole. A submerged pit approximately 55 meters deep and 60 meters in diameter within the Sac Octun system. On its floor lay the skeleton of a girl. She was 15 or 16 years old when she died. Researchers named her Naica. Radiocarbon dating placed her at approximately 12,900 to 13,000 calendar years before present. One of the oldest and most complete human skeletons in the Americas. Surrounding her were the remains of at least 26 large Pleistocene mammals. Mitochondrial DNA extracted from Naica's molar revealed haplogroup D1, ancestral to modern Native American populations. James C. Chatters led the paper, published in Science, volume 344, in May 16, 2014. It resolved a decades-long paradox. Early American skulls look morphologically different from modern Native Americans. Some researchers had argued this meant separate migration waves. Naica's DNA proved otherwise. Same lineage, different skull shape. The difference was microevolution, not separate ancestry. The Megafauna inventory reads like an Ice Age bestiary. Gomphotheres, giant ground sloths, saber-toothed cats, glyptodonts, American horses, American camels, tapirs. Many skeletons were articulated, meaning the bones remained in anatomical position. These animals did not wash in. They walked in when the caves were dry and air-filled. Then the water came. At roughly 8 to 10 meters depth, a halocline divides fresh water from salt water. Below it, anoxic conditions preserve bone collagen for radiocarbon dating and ancient DNA extraction. Deeper still, hydrogen sulfide layers create toxic milky white chemoclines, supporting chemolithotrophic bacterial mats and blind cave-adapted fauna. Typhlotia, shrimp. The blind cave fish, Opister non infernale, a sunlight-independent ecosystem thriving in the same tunnels that hold Pleistocene bones. The mainstream position holds that Naica's haplogroup D1 demonstrates in situ microevolution. A pre-Clovis coastal theory, advanced by Wolfgang Stinisbeck's team at Heidelberg University, argues some cenote remains predate 13,000 years before present, supporting a kelp highway coastal migration route that aligns with Monteverde in Chile at approximately 14,500 years before present. A more speculative theory suggests the sheer density of early human remains in cenotes may not be entirely accidental. The Maya considered cenotes sacred portals to Xibalba, the underworld. Some patterns of deposition are difficult to explain by chance alone. At Chanhole Cave, Stinisbeck used uranium-thorium dating of overlying speleothems to establish minimum ages of 9,900 to 11,300 years before present. A portion of the Chan Hole 3 skull was looted by unknown illegal divers between research dives. Tourism contamination is measurable. Tulum's population explosion from roughly 15,000 in 2005 to over 35,000 by 2020 has introduced fecal coliform bacteria and nitrate loading into the cave aquifer. The caves are being loved to death, and every pore fin kick creates a silt out that reduces visibility from over 100 meters to 0 in under 10 seconds. That is how divers die underground. But everything we have discussed so far exists within reach. Difficult reach, dangerous reach. But theoretically reachable by a human body with enough training and equipment. The next trapped world is not. Number 3, Earth's mantle ocean. This is not an ocean you can swim in. It is not liquid. It is not blue. It exists at pressures and temperatures no human technology can survive, locked inside the crystal lattices of minerals 410 to 660 kilometers beneath your feet, and it may hold more water than every ocean on the surface combined. In 2014, a 40 micrometer mineral inclusion was found inside a diamond from the Guiana region of Mato Grosso, Brazil. The mineral was ringwoodite. It contained approximately 1.5% water by weight, stored as hydroxyl groups. Graham Pearson at the University of Alberta published the finding in Nature, volume 507. He had not been looking for it. He was searching for carbonate inclusions. The diamond had acted as a perfect pressure vessel, shielding the ringwoodite from phase transformation during its violent ascent from the mantle. 3 months later, on June 13, 2014, Stephen Jacobson at Northwestern University and Brandon Schmont at the University of New Mexico published in Science, volume 344. They had found seismic evidence for a water-saturated mantle transition zone beneath North America at approximately 660 kilometers depth. Ringwoodite is a high-pressure polymorph of olivine, magnesium 2 silicon oxide 4. It forms a spinel crystal structure and dominates the mantle between roughly 520 and 660 kilometers depth. It was named after Australian geochemist Alfred Ringwood, who predicted its existence in the 1960s. It was first identified in the Tenham meteorite, which fell in Queensland, Australia in 1879. The water is not liquid. It exists as hydroxyl groups substituted into crystal lattice defect sites. Structural water, locked in atomic architecture. Ringwoodite can hold up to 2 to 3% water by weight. The mantle transition zone sits at 410 to 660 kilometers depth. Pressures of 13 to 24 gigapascals. Temperatures of approximately 1,400 to 1,700 degrees Celsius. The volume estimate is staggering. The transition zone may hold water equivalent to 1.5 to 5 times all surface oceans. Approximately 1.335 billion cubic kilometers of water sits on Earth's surface. Multiply that by up to 5. And it may have been there since the planet formed over 4.5 billion years ago. At 660 kilometers, ringwoodite breaks down into bridgemanite and ferropericlase. Neither mineral can hold significant water. The stored water is squeezed out, triggering dehydration melting. Jacobson and Schmont detected this using the US Array, a rolling network of roughly 2,000 seismometers deployed across the United States as part of the NSF-funded EarthScope project. S-waves cannot travel through liquid. Their attenuation at 660 kilometers was the melt indicator. The signal mapped across the entire continental interior of North America. The mainstream theory holds that water entered the transition zone via subducting oceanic crust. Hydrated minerals like serpentine, amphibole, and phengite carry water deep. At transition zone depths, wadsleyite and ringwoodite absorb it efficiently, acting as a water trap. The alternative theory proposes that some of this water is primordial, incorporated during planetary accretion from water-bearing chondrite asteroids more than 4.5 billion years ago, meaning this reservoir may predate Earth's surface oceans entirely. Hans Kepler at the University of Bayreuth has challenged the highest estimates, arguing the transition zone may be only 0.1 to 0.5% saturated. Temperature anomalies and iron content can mimic a melt signal in seismic data. The hydrogen isotope ratio of mantle-derived water differs slightly from surface ocean water. This suggests complex mixing between mantle, surface, and extraterrestrial sources. Joseph Smith at the University of Colorado Boulder demonstrated in the 1980s and 90s that wadsleyite and ringwoodite could store hydroxyl groups. Shunishiro Karato at Yale showed that water weakens mantle mineral lattices, making wet rock flow more easily. This directly affects plate tectonic velocities. The deep water cycle may function as a planetary thermostat, regulating how much water remains at the surface over billions of years. It may explain why Earth has maintained liquid oceans despite changing solar luminosity. No drill has ever penetrated deeper than 12.3 kilometers. The Kola Superdeep Borehole. The Mantle transition zone is 30 to 50 times deeper. We cannot reach it. We may never reach it. But we found its fingerprint in a diamond the size of a grain of sand. And sometimes the thing you cannot reach is not deep beneath the earth. Sometimes it is right in front of you, in a room you can stand in, and it will kill you in 10 minutes. Number 4. The Naica Crystal Cave, Mexico. In April of 2000, brothers Juan and Pedro Sanchez were drilling a new tunnel 300 meters below the surface in the Naica silver-lead-zinc mine, Chihuahua, Mexico. The mine is operated by Industrias Peñoles, Mexico's largest silver producer. They broke through into a chamber roughly 30 meters long and 10 meters wide. Inside were the largest natural crystals ever documented on Earth. The biggest measures approximately 12 meters long and 4 meters in diameter. Estimated weight 55 metric tons. They are composed of selenite, a transparent variety of gypsum, calcium sulfate dihydrate. They cross the chamber like interlocking structural beams, filling the space at every angle. The ambient temperature is 58 degrees Celsius. Humidity is near 100%. At those conditions, the human body cannot cool itself. Sweat cannot evaporate. Fatal hyperthermia sets in within approximately 10 minutes without protection. Respiratory distress from superheated saturated air occurs even faster. Researchers use custom ice refrigerated cooling suits, circulating ice water through tube networks. Even fully suited, excursions are limited to 45 minutes to 1 hour. Juan Manuel Garcia Ruiz at the University of Granada published the growth mechanism in geology in 2007. The crystals grew at precisely 58 degrees Celsius in a narrow thermal sweet spot where anhydrite slowly dissolves and reprecipitates as gypsum selenite. Uranium-thorium dating suggests they began growing approximately 500,000 years ago. Some grew continuously for up to 990,000 years, at rates of approximately 1 to 4 millimeters per century. The crystals are optically clear enough to see your hand through. That transparency results from extremely slow, ordered growth with minimal crystal defects. Penelope Boston, then director of the NASA Astrobiology Institute at NASA Ames, extracted fluid inclusions from the selenite crystals, microscopic pockets of ancient water estimated at 10,000 to 50,000 years old. Inside, she found dormant microbial life. She successfully revived it in the laboratory. The organisms were phylogenetically novel, not closely related to any known database species. They thrived on iron, sulfur, manganese, and copper compounds. Chemolithotrophic metabolisms. She presented the findings at the AAAS annual meeting in February 2017. The mainstream scientific community urges caution. The results remain preliminary and unpublished in a peer-reviewed journal. The cave sits in an active mining environment visited by many people. Contamination cannot be ruled out. But the microbe's phylogenetic novelty and chemolithotrophic metabolism are consistent with a genuine ancient deep biosphere community sealed in fluid inclusions during crystal growth. Similar organisms have been found in other deep subsurface environments worldwide, and if they genuinely survived 50,000 years of dormancy in nanolighter fluid pockets, it would represent one of the longest confirmed periods of viable microbial preservation in a non-frozen, non-halite environment. Pumping operations that had kept the cave drained halted in 2015 when lead-zinc extraction became uneconomical. By 2017, the cave was confirmed fully reflooded. Crystal growth has theoretically resumed. During the roughly 15-year accessible period, some crystal damage occurred from untrained visitors. The reflooding may have been the best conservation outcome. Garcia Ruiz's parallel work on biomorphs, inorganic mineral structures that mimic biological shapes, serves as a methodological caution for Mars sample return science. And gypsum is abundant on Mars, confirmed by Mars Express in the Opportunity rover. Naica's demonstration that gypsum fluid inclusions can host and preserve biosignatures is directly relevant to where we point our next spacecraft. But the crystal cave preserved microbes for tens of thousands of years. The next trapped world held an entire ecosystem frozen for hundreds of thousands. And the thing that sealed it was not rock or crystal, it was ice. 2 kilometers of it. Number 5, Greenland sub-ice fossil tundra. Camp Century was built between 1959 and 1960 by the United States Army Corps of Engineers beneath the Greenland ice sheet. Roughly 200 kilometers east of Thule Air Base, at approximately 1,885 meters elevation. It was powered by the PM2, a portable nuclear reactor producing roughly 1.5 megawatts, the first operational nuclear power plant in the Arctic. But Camp Century was a cover story. The real project was Iceworm, a classified plan to build 4,000 kilometers of railway tunnels under the ice sheet for up to 600 nuclear ballistic missiles aimed at the Soviet Union. It was abandoned by 1966 when ice deformation made the tunnels structurally unstable. The plan was declassified only in 1995. Denmark, which governed Greenland, was never informed of the nuclear missile plans. The declassification caused significant diplomatic controversy. During Camp Century's operational years, the Cold Regions Research and Engineering Laboratory drilled an ice core from 1963 to 1966, led by glaciologist Chester Langway. They reached 1,387.4 meters using a thermal electric drill, the first ice core to reach bedrock in Greenland. At the very bottom sat roughly 3.5 meters of sub-ice material, frozen sediment, silt, sand, and organic matter resting on bedrock. It was bagged, sent to CRR-EL freezers in Hanover, New Hampshire, and largely forgotten for 50 years. When Langway died in 2017, colleagues sorting his archives brought the samples to a new generation's attention. Andrew Christ at the University of Vermont, working with advisor Paul Bierman, examined the sediment. It contained well-preserved plant fossils, leaves, seeds, mosses, twigs retaining original structure, waxy leaf coatings, insects, a developed soil profile, a paleosol, requiring thousands of years of ice-free conditions to form. The plant material was macroscopically visible with the naked eye. Infrared stimulated luminescence dating indicated last exposure to sunlight at least 416,000 years ago, possibly over 1 million years. Cosmogenic nuclide. Dating using beryllium-10 and aluminum-26 ratios confirmed prolonged burial. The leading candidate is marine isotope stage 11, roughly 400,000 to 420,000 years ago. One of the warmest and longest interglacials of the past 800,000 years. The critical implication lands like a gut punch. MIS-11 was only 1 to 2 degrees Celsius above pre-industrial temperatures, comparable to what Earth is approaching right now. Christ and colleagues published the landmark paper in PNAS in March 2021, volume 118, number 13. A 2023 follow-up in Science examined sediment from the GISP2 core at Greenland summit. The central ice sheet also disappeared or dramatically shrank within the past million years. Summit ice-free for at least 280,000 years during the Pleistocene. The mainstream theory now holds that the Greenland ice sheet has been dynamic. It shrank substantially and regrew multiple times. This forces a major revision from prior assumptions of continuous glaciation for at least 2.5 million years. A more conservative view argues for ice persistence at the summit even during warm interglacials, based on preservation of very old ice at the bottom of the GISP2 and NEAM cores. The Camp Century site may have deglaciated while the interior remained. The alarming extrapolation is direct. If 1 to 2 degrees of warming collapsed the ice sheet before, current trajectories guarantee partial or total Greenland deglaciation within centuries. The entire Greenland ice sheet melting yields approximately 7.2 meters of global sea level rise, 23.6 feet. William Colgan at the Geological Survey of Denmark and Greenland published a 2016 study warning that rising temperatures could melt ice covering Camp Century within this century, potentially releasing 200,000 liters of diesel fuel, 240,000 liters of wastewater, and unknown quantities of radioactive coolant left behind when the base was abandoned. The Cold War's waste, thawed by the warming it helped build. But Greenland's fossils are hundreds of thousands of years old. The next trapped world holds organisms more than 1,000 times older, 830 million years, sealed inside crystals of salt. Number 6. The 830 million year old halite organisms. In May of 2022, Sarah Schroeder-Gomez, Kathleen Benison, and Jeremiah Burnau, all at West Virginia University, published a paper in Geology Volume 50, pages 840 through 844. They had found microorganisms inside salt crystals from the Brown Formation in the Officer Basin of Central and Western Australia. The crystals are approximately 830 million years old. Tonian period, Neoproterozoic era. The supercontinent Rodinia was at or near maximum assembly. Inside primary fluid inclusions within chevron halite crystals, they identified both prokaryotic cells and eukaryotic algae resembling modern Dunaliella. A halophilic green alga, among the most salt-tolerant eukaryotes known. The eukaryotic cells range 5 to 15 micrometers. Some showed possible internal structure, including what may be nuclei or organelles. Orange coloration was consistent with beta-carotene, a UV protectant pigment that Dunaliella produces abundantly, up to 10% of dry weight, a pigment stable over geological timescales. All observations were made non-destructively through intact unbroken crystals, transmitted light petrography and UV-vis fluorescence petrography. Organic molecules fluoresce under UV, distinguishing biological material from inorganic salt. The chevron growth habit, a distinctive V-shaped pattern forming at evaporating brine surfaces, cannot form during recrystallization. This proves the inclusions are original, not secondary contamination. At 830 million years, these organisms lived roughly 300 million years before the Cambrian explosion, more than 4 times older than the dinosaur extinction. They predate the cryogenian snowball Earth glaciations, the Sturtian at approximately 717 million years ago, and the Marinoan at roughly 635 million years ago, by 100 million years. The atmosphere was undergoing a second oxygenation event. Multicellular eukaryotes were just appearing. The concept of an animal did not yet exist. The mainstream theory holds that these are exceptionally preserved cellular remains, husks, morphological ghosts. But dead. 830 million years of cumulative background radiation damage to DNA is incompatible with viability. Lipid membranes degrade over millions of years even without enzymatic activity. The optimistic theory points to the extraordinary conditions inside the crystal. Halophiles enter metabolic dormancy in saturated brines. The crystal matrix provides radiation shielding. Water activity of approximately 0.75 in saturated sodium chloride severely slows all degradation reactions. Modern Haloarchaea carry 10 to 25 genome copies with redundant DNA repair pathways, conditions that favor extreme longevity. In 2000, Russell Vreeland, William Rosenzweig, and Dennis Powers claimed in Nature, volume 407, to have revived a living bacterium from 250-million-year-old Permian halite from the Salado Formation in New Mexico. The claim remains highly controversial. The revived organism's 16S ribosomal RNA sequence was nearly identical to modern bacillus, statistically inconsistent with 250 million years of molecular evolution. The 830-million-year-old organisms push the record 580 million years further back, and here lies the preservation paradox. You cannot culture without contaminating. You cannot confirm viability without culturing. You cannot open the crystal without destroying the evidence of age. This may be the only discovery in this video where the question itself, are they alive, is permanently unanswerable without destroying the artifact that makes it meaningful. The Brown Formation represents a saline lake or marine evaporite environment accessed via drill core samples. Mars has halite and evaporite deposits confirmed by CRISM on Mars, Reconnaissance Orbiter and rover data in Gale Crater and Jezero Crater. Deposited during the Noachian and Hesperian periods when liquid water existed. The non-destructive UV-vis fluorescence methodology is directly applicable to planetary instrument design. These organisms lived closer in time to the formation of the first eukaryotic cells than to us, yet they sit inside a mineral you can hold in your hand. Salt preserves by exclusion. It locks biology inside and chemistry out. But there is another transparent mineral matrix that preserves by entombment. And it captures not just cells, but entire bodies, feathers, behaviors, frozen mid-motion in 3 dimensions. It also happens to come from an active war zone. Number 7, 99 million. Year-old Kachin amber, Myanmar. The deposits lie in the Hukong Valley, Kachin State, northern Myanmar, near the village of Tanai. Uranium lead zircon, dating of interbedded volcanic ash, places the amber at approximately 98.8 to 99 million years old, mid-Cretaceous, Cenomanian stage. The resin producers were likely trees of the Araucariaceae family. Specimens are extracted by artisanal miners digging 10 to 30 meter tunnels into hillside sediments using hand tools, in a conflict zone that has been in armed conflict since 1961. In December 2016, Lida Xing described a 1.4 centimeter section of non-avian theropod dinosaur tail. Specimen Eva. It contained 8 vertebrae, soft tissue, and chestnut brown and white banded pennaceous feathers. Published in Current Biology, purchased at the Maidkini market for roughly $1,000. Ricardo Perez de la Fuente and Ryan McKellar described Denocroton draculae, Dracula's terrible tick, found adjacent to dinosaur feathers, and Cornipulpatum bermanicum still attached to a dinosaur feather. The first direct physical evidence that ticks parasitize dinosaurs. Electra Rana Limoyer, published in 2018 in Scientific Reports, represented the oldest known tropical rainforest frogs, pushing the fossil record back by tens of millions of years. Xiaophis myanmarensis, a snake with roughly 100 vertebrae, established that snakes originated in forest ecosystems. In 2017, the predatory ant Lingomar mex vladii was described with metal-reinforced mandibles, high zinc concentrations detected via synchrotron X-ray fluorescence, preserved after 99 million years, a pseudoscorpion clinging to a fly's leg, Foricea frozen in amber, a harvestman preserving an erect penis, the oldest known record of a male intromittent organ in any animal. Over 1,000 new species have been described from Kachin amber. Estimates suggest over 10,000 total possible. More than 300 spider species alone. More than from any other single fossil deposit on Earth. The preservation is three-dimensional. CT scanning reveals full volumetric data, cellular level detail, individual feather barbules, muscle fiber textures, even sperm cells in a 2020 ostracod study. Ancient DNA, however, has not been successfully recovered. 99 million years far exceeds DNA's theoretical maximum survival time of roughly 1 million years under ideal cold conditions. Jurassic Park remains fiction. Then came the debacle. In March 2020, Lida Xing and Jingmai O'Connor described Oculodentavis in Nature as the smallest known Mesozoic dinosaur. A skull 7.1 millimeters long. Estimated body weight 2 grams. Within weeks, Andrea Kao and others demonstrated it was a squamate, a lizard. Nature retracted the paper in July 2020, one of the fastest high-profile retractions in paleontology. The ethical fracture runs deeper. In June 2020, the Society of Vertebrate Paleontology published an open letter signed by hundreds of paleontologists calling on journals to stop publishing new species from Burmese amber of uncertain provenance. The argument is that publication drives commercial demand and funds the armed conflict between the Myanmar military and the Kachin Independence Army. The counter-argument, advanced primarily by Chinese researchers with the greatest access, holds that refusing to describe already sold specimens destroys scientific data while doing nothing to stop the trade. The amber is already extracted regardless of academic publication decisions. Myanmar's military coup of February 2021 significantly worsened conditions in Kachin State. The ecosystem these amber pieces collectively document is a mid-Cretaceous greenhouse rainforest with no polar ice caps, the most complete snapshot of a single deep-time ecosystem ever assembled, piece by piece, from a deposit that remains largely in the ground. In an active war zone, the amber preserves individuals, single organisms frozen in single moments. The next trapped world preserves something different, a single species that constitutes an entire ecosystem, one organism, every metabolic role. 3 kilometers underground. Number 8, the Witwatersrand. Deep Biosphere, South Africa. The Amponing gold mine, operated by Anglo Gold Ashanti, sits southwest of Johannesburg in the Witwatersrand Basin. It is the deepest operating gold mine in the world. Workings extend to approximately 4 kilometers. In fracture water at roughly 2.8 kilometers depth, researchers found a single species of bacterium running an entire ecosystem alone. Dylan Chivian at Lawrence Berkeley National Laboratory led the paper, published in Science in 2008, volume 322, pages 275 through 278. Tullus Onstad at Princeton was key co-author and principal field scientist. They named it Candidatus desulphuretus audax viator, Latin for bold traveler. A reference to the inscription in Jules Verne's 1864 Journey to the Center of the Earth, signed by the fictional alchemist Arne Segnusem. Descende, audax viator. The organism accounted for more than 99.9% of all microbial sequences recovered. The first documented single-species ecosystem on Earth. One organism performing all metabolic roles. Producer, consumer, recycler. Its energy source is hydrogen produced by radiolysis. Ionizing radiation from the decay of uranium-238, uranium-235, thorium-232, and potassium-40 splits water molecules. Water becomes hydrogen and hydrogen peroxide. The entire ecosystem is powered by radioactive decay, zero sunlight dependence. It couples hydrogen oxidation to the reduction of sulfate to hydrogen sulfide. The sulfate itself comes from radiolytic oxidation of pyrite. The complete energy cycle driven by uranium decay. The fracture water has been dated by noble gas isotope accumulation. Helium-4, neon-21, argon-40, xenon-136. Isolated from the surface for tens of millions to more than 2 billion years. Tritium is completely absent, confirming no surface water input since the 1950s. Li Hung Lin at National Taiwan University led the Water Age study, published in Science in 2006, volume 314. The genome is approximately 2.35 million base pairs, 2,157 genes, reconstructed entirely from environmental metagenomic DNA. It has never been grown in pure culture. It carries complete dinitrogenase for nitrogen fixation. The Wood-Ljungdahl pathway for carbon fixation. It synthesizes all 20 amino acids and all vitamins. Temperature at depth runs 48 to 60 degrees Celsius. Pressure sits at 280 to 300 atmospheres. Cell density is approximately 10,000 cells per milliliter. Sparse, but metabolically active. The organism has two complete sets of chemotaxis genes to swim toward hydrogen hotspots near radioactive mineral grains in the microfracture network. Nearly identical strains have been found in deep mines in Canada, Finland, and the United States. The mainstream interpretation is radiolysis-driven chemistry in ancient fracture water. An alternative theory suggests the identical strains found globally represent very ancient dispersal via endospore migration through deep crustal fracture networks, a hidden planetary biosphere connected across continents. A third theory proposes convergent evolution. The deep subsurface may reliably produce this same metabolic solution under identical selective pressures. In June 2011, Gaëtan Bourgogny at the University of Ghent and Onstad published in Nature the discovery of Halocephalobus mephisto, a multicellular nematode living at 0.9 to 3.6 kilometers depth, the deepest living animal ever discovered. Feeding on bacterial biofilms, named after Mephistopheles from Goethe's Faust. Barbara Sherwood Lawler at the University of Toronto reported in Nature in 2013 that fracture waters from Kidd Creek Mine in Ontario, Canada, showed noble gas signatures indicating isolation for up to 2.64 billion years, the oldest known freestanding water on Earth. And then Cassini changed the conversation. In 2017, the spacecraft detected hydrogen in the plumes of Saturn's moon, Enceladus. Hydrogen produced by water-rock reactions, the same chemistry powering the Witwatersrand biosphere. Desulphuretus audax viator is NASA's primary terrestrial analog for potential subsurface life on Mars, Europa, and Enceladus, a single species running an entire world, on radiation and water, 3 kilometers down. But the Witwatersrand biosphere is invisible. You cannot see it without a gene sequencer. The next trapped world is the opposite. You can see the bones, you can see the fur, you can see exactly how they died. Because they fell. Number 9. The Nullarbor Cave Megafauna Tombs, Australia. The Nullarbor Plain stretches roughly 200,000 square kilometers across southern Australia. Beneath it lies Eocene to Miocene marine limestone deposited 35 to 14 million years ago. One of the largest single exposures of limestone in the world, Rainfall is as little as 200 to 250 millimeters per year. The surface is flat, featureless, and riddled with holes. The Thelocaleo caves sit near the Hampton Tableland in Western Australia's Roe Plains region. Their precise locations are deliberately withheld from public literature to prevent unauthorized disturbance. Gavin Prideaux at Flinders University led the landmark study, published in Nature in 2007, volume 445, pages 422 through 425. 23 vertebrate species, 8 macropod species, from a single cave system. The mechanism is brutally simple. Animals walked over deceptively small sinkholes, 1 to 2 meters in diameter, and fell into chambers 20 to 30 or more meters deep. No gnaw marks on the bones. No feeding disarticulation. These were not predator accumulation sites. These were accidental deaths. And they cascaded. Multiple individuals of the same species at the bottom of a single shaft. Animals heard or smelled others trapped below, approached the edge and fell in themselves. Accumulation over hundreds of thousands of years. Thelocaleo carnifex, the marsupial lion, the largest marsupial predator that ever lived. Estimated 100 to 130 kilograms, with the highest bite force quotient of any known mammalian predator. More than 1,500 newtons at the carnassials, previously known almost entirely from fragmentary jaw material. The Nullarbor specimens revealed the full animal. Enormously enlarged blade-like third premolars functioning as shearing carnassials, not canines. Premolars. Semi-retractile claws on powerful forelimbs built for ambush grappling, a stiffened tail functioning as a tripodal prop, a robust clawed hallux suggesting tree climbing ability, an apex predator that hunted from above. The Megafauna roster reads like an inventory of a lost continent. Procoptodon, Goliah, the giant short-faced kangaroo, up to 2 meters tall, roughly 230 kilograms. Zygomaturus trilobus, a hippo-like diprotodontid, approximately 500 kilograms. Palurkestes, a tapir-like marsupial with a prehensile snout. Phascolonus gigas, the giant wombat. Megalobguilii ramsayi, a giant echidna. And the thylacine. The primary assemblage dates to roughly 200,000 to 400,000 years before present by uranium, thorium, and optically stimulated luminescence, significantly predating any proposed human arrival in Australia at roughly 50,000 to 65,000 years ago. Many skeletons are fully articulated, bones in anatomical position. Some retain ligaments, tendons, dried cartilage. In rare cases, traces of hair or skin. Bone surfaces are frequently unfossilized, retaining original collagen structure. The extreme aridity, stable temperatures, absence of scavengers, and sealed chambers produce preservation that makes the bones look freshly deposited rather than ancient. The mainstream theory holds that these same species survived roughly 400,000 years of repeated glacial-interglacial climate shifts and then vanished rapidly after human arrival, supporting human hunting pressure as the primary extinction driver. The climate theory counters that megafauna decline was driven by increasing aridity across the late Pleistocene. Humans merely delivered the final stress on already declining populations. Prideaux's team demonstrated that the Nullarbor megafauna were well adapted to arid conditions, challenging older assumptions that restricted megafauna to wetter regions. But the synergistic collapse theory may be closest to the truth. Sustained hunting on long-lived, slow-reproducing species during a drying climate may have been uniquely lethal. Many shafts require technical rope descents of 20 to 40 meters through narrow passages. Some chambers are accessible only through flooded passages requiring cave diving. Some bone-bearing chambers are visible through gaps but physically unreachable. The vast majority of fossil material remains in situ, unrecovered. What has been published represents a fraction of what lies in the dark. Comparable sites exist: Natural Trap Cave in Wyoming, Rancho La Brea in Los Angeles. But the Nullarbor is distinctive for producing articulated, undisturbed skeletons in a quantity and preservation state that surpasses most comparable sites worldwide. The remoteness that makes them hard to study is the same remoteness that preserved them. Every trapped world so far has been static. sealed, frozen, locked. The final one is not. It moves, it churns, it swallows things and spits them back out. And people mine it for road pavement. Number 10. The Pitch Lake of Trinidad. La Brea, borough of Siparia, southwestern Trinidad. The largest natural asphalt lake in the world, approximately 40 hectares. Estimated depth 75 to 80 meters. Total volume approximately 6 million cubic meters of natural bitumen, and you can walk on it. If you stand still too long, it'll swallow you. The composition is roughly 40% bitumen, 30% mineral clay, and 30% emulsified water as microscopic droplets. A non-Newtonian material firm enough to support your weight, but viscous enough to flow over decades. A major geological fault, the Los Bajos Fault System, intersects a subsurface petroleum reservoir. Heavy crude migrates upward. Lighter volatiles escape, leaving accumulating bitumen. The seepage has been ongoing for at least tens of thousands of years. Sir Walter Raleigh visited in 1595 during his first Orinoco expedition. He used the pitch to caulk and waterproof his ships. Documented in The Discovery of the Large, Rich, and Beautiful Empire of Guyana, published 1596. The lake churns slowly. Convective movement driven by upward hydrocarbon seepage pushes objects at centimeters per year in the active central zone. Footprints heal within hours to days. Gas bubbles of methane and hydrogen sulfide regularly break the surface, and the churning brings things up. Pleistocene megafauna bones. Giant ground sloths, mastodons, glyptodonts, prehistoric horses, ancestral tapirs. Ancient tree trunks in remarkable preservation. Radiocarbon dating of organic material yields roughly 10,000 to 40,000 years before present, but the petroleum environment contaminates samples with old carbon, complicating all dating efforts. Most finds are serendipitous, discovered by workers during mining. The pitch flows back to fill any excavation almost immediately. There's no way to hold a dig open, materials emerge unpredictably from depth. Dirk Schulze-Makuch, then at Washington State University, and colleagues published in Astrobiology around 2011, a finding that redefined what the lake is. Active microbial communities living inside tiny water droplets distributed throughout the pitch matrix. Droplets, often only micrometers to hundreds of micrometers in diameter. Cell counts within the water and asphalt emulsion reach 10 to the 7th cells per milliliter of water within the droplets, comparable to productive soil environments, not the near zero expected in such a toxic medium. The microbial community includes sulfate-reducing bacteria producing hydrogen sulfide, explaining the sulfurous smell. Methanogenic archaea producing methane, explaining the surface gas bubbling. Hydrocarbon-degrading bacteria, and novel previously undescribed lineages identified via 16S ribosomal RNA sequencing. Each water droplet functions as a micro-oasis, an isolated tiny biosphere with its own dissolved salts, nutrients, and microbial metabolic byproducts. The microbes actively modify their microenvironment within the water-repellent pitch. The mainstream interpretation treats the lake as a natural trap, analogous to the La Brea tar pits. Animals became mired, died, and were preserved. The continuous churning is both the preservation mechanism and the obstacle to systematic study. A deeper theory proposes that the megafauna bones at depth may represent animals from periods when the lake's surface was fundamentally different, possibly more liquid during warmer Pleistocene interglacials. The current semi-solid state may not reflect the conditions under which entrapment occurred. A faunal exchange theory notes that during glacial low sea stand periods, Trinidad may have had land connections to mainland South America, explaining how Pleistocene megafauna reached the island. Lake asphalt of Trinidad and Tobago extracts approximately 150,000 to 200,000 tons annually. Yet the lake has not been measurably depleted because continuous subsurface seepage replenishes it. Active for over 150 years. Fifth Avenue in New York was paved with Trinidad lake asphalt in the 1870s and 1880s. Central zone surface temperatures reach 50 to 60 degrees Celsius. Hydrogen sulfide outgassing is a genuine safety concern. And then there is Saturn. Titan has surface lakes of liquid methane and ethane. Ligeia Mare, Kraken Mare. Structurally analogous to the Pitch Lake's hydrocarbon matrix, Schulze-McCouch has explicitly cited the Pitch Lake as a Titan analog for astrobiology. Indigenous Arawak and Carib peoples used the pitch for waterproofing canoes long before the European contact. Some oral traditions describe an entire village swallowed by the earth and replaced by the lake as divine punishment. The Pitch Lake is simultaneously ancient trap, living ecosystem, commercial resource, cultural artifact, and active geological process. The most multivalent trapped world in this video. Every world in this video was preserved precisely because it became unreachable. The seal is the preservation. Sealed caves, frozen ice, crystal lattices, mineral matrices, volcanic diamonds, flowing pitch. The mechanism differs, the principle is identical. No technology we currently possess can reach the Mantle transition zone, fully excavate a flowing tar lake, or open a halite crystal without destroying what is inside. The organisms in Movile Cave evolved for 5.5 million years because nothing disturbed them. The Greenland tundra survived because the ice buried it. The amber preserved feathers because resin hardened around them. In every case, the moment of discovery threatens the preservation. Entering changes the atmosphere. Melting reveals and destroys. Opening the crystal ends the experiment. From 99 million-year-old amber to a 4.5 billion-year-old Mantle reservoir, Earth has been trapping worlds since before life existed. The most complete record of this planet's past is not in any museum, it is locked in the planet itself, in places we may never reach.